Today, we are going to begin by reviewing how to graph a piecewise function. And then after we can graph a piecewise function, we're going to evaluate some limits at various x values. We're going to use this function f of x to review graphing those piecewise functions. There's lots of ways that you can tackle graphing piecewise functions, but the way I like to think of it is just like the name, graphing pieces of functions. F of x in this case is like 5 little mini equations. Let's start by graphing the first one. If I graph y equals negative x plus 1, I get this line, and then we only want to use the piece from 0 to 1. I'm going to put in a rectangle from 0 to 1 to try to emphasize what piece we're going to use. So putting that in, go right there and stop it there. Okay, we only want to use that piece. Here, I'm just leaving out anything to the left of 0 or the right of 1. If I leave out everything outside of the interval 0 to 1, I have that little piece right there. But now I need to consider those endpoints. Since we have less than or equal to for the 0, the endpoint on the left is going to be a solid dot, and then plain less than 1, that's going to be an open dot for the endpoint. So let's put in a closed dot and an open dot. Here's my closed dot, endpoint, and my open dot. Now that we have the piece of y equals negative x plus 1 from 0 to 1, let's transfer that to the main graph of f of x. Moving that on over. Here is the first piece of the graph of f of x. We just need to repeat this process for each one of these equations. Here I have graphed y equals 1. Y equals 1 is just a horizontal line that goes through the y-axis at 1. If this would have been x equals 1, well then we would have had a vertical line going through the x-axis at 1. All right, so now we want to just use the right piece of y equals 1. We would like to use just the piece from 1 to 2. So I'm going to put in a rectangle from 1 to 2, again, just to emphasize which piece we're going to use. Here I have drawn the piece from 1 to 2. The left side endpoint is a closed dot because it was 1 is less than or equal to. The right side endpoint is an open dot because it was plain less than 2. So let's now transfer this piece of y equals 1 over to our main graph. All right, so we have our second piece. On to our third piece. I've graphed the third mini equation, y equals 2, which again is just a horizontal line at 2 going through the y-axis. And this one, we're only going to use the piece x equals 2. We do not have an interval from one number to another number. We just want to keep it at x equals 2. So if I put in that rectangle, it would be infinitely thin there. It would only be a line at 2 and not from one number through a number. So if we only keep this little piece, it's really just a point that we're keeping. So if we're just keeping that one spot at 2, the only part we're keeping is that little bit right there. So our third piece is only a coordinate. Let's go ahead and transfer that point over to our main graph. And there we have it. I've graphed y equals x minus 1 here. I only want to keep from 2 to 3. So I'm going to put in a rectangle that illustrates what piece that I want to keep. So here's the piece we're going to keep, and we want to transfer that over to our main graph. So I'm moving this over to the main graph. This piece lands right there. Right there. Okay, so now for the fifth and final piece. I've graphed the equation y equals negative x plus 5, but we only want to keep the piece between 3 and 4. I'm just going to say all of a sudden I realize keep the piece between 3 and 4. Sorry, that sounds a little funny. Like outside of 3 and 4, oh, crazy. All right, so sorry, silly. Oh my gosh. All right, I'll just keep going. So we're going to keep from 3 to 4. So I'm going to put in a rectangle from 3 to 4, and we're only going to keep that piece because it's crazy outside. All right, so keeping that piece, it's going to look like that. And so the endpoint was an open dot there at 3 and a closed dot at 4 because of the less than or equal to. Now I want to transfer this piece over to the main graph, so let's do that. Okay, let's move this piece on over, but I want you to notice something that's happening here. We have an open dot that is landing on top of a closed dot. And when I let go here, notice that it's filled in. That purple closed dot is filling in and filling in that point. So this is our final graph of f of x. Now that we've reviewed graphing a piecewise function, again, the way that I go about it is I just graph the individual equations and just use pieces of them. But now we're going to work on some calculus because you have to, in tonight's assignment, be able to graph a piecewise function, and then after you've graphed the piecewise function, you're going to find some limits at some x values of that piecewise function. So let's add that piece in. Ha, no pun intended. For this question, we have already graphed f of x. That's what we just did. And then next, let's say that we want to determine from the graph what is the limit as x approaches c from the right and from the left. You're like, what's c? Well, c, they're going to have to give you c. So let's say given that c equals 1. If c equals 1, I'm going to replace the c values with 1. And I'm just going to warn you, I wrote it this way. I really think it looks weird because notice I put the limit as x approaches 1 from the right on the left side of the paper. And that's what they did in the homework assignment. And so it's easy to make a careless mistake there. So we're going to read that very carefully. The limit as x approaches 1 from the right. So we're going to go to the picture here and we're going to get really, really close to 1. Coming in from the right side, so we're heading to a height of 1. And then the next one there, the limit as x approaches 1 from the left. So coming in from the left, getting close to x equals 1, we're heading to a height of 0. So now we've answered those two questions. Okay, and then lastly, carrying over what we've done so far, we're going to be asked to write in our own words here, does the limit exist as x approaches c of f of x? And they want you to explain. I wrote here, explain using the Sloth definition and also formally, because we really want to keep those two straight because the Sloth definition is not enough to explain on the AP exam, but it does help us quickly get the answers. All right, so let's start. I replace the c there with 1 since our c value is 1. Start with the sloth. Well, we go over to 1 and there's a break. And we know that if at that x value there is a break or there's an asymptote, well then the limit is not going to exist. So we know it does not exist. But if we want to formally give an explanation of why the limit does not exist as x approaches 1. We need that 3-step process. All right, so step number 1 and step number 2, we already did in part B. We already found the limit as x approaches 1 from the right and from the left. Specifically, what that's doing for us in the definition is we just showed that the limit as x approaches 1 from the right exists because it has an answer, and the limit as x approaches 1 from the left exists because it has an answer. All right, then the third step is the limit from the right and left have to equal each other, but in this case they do not, because 1 does not equal 0. So sending the sloth there up next to the fact that it was a break, we're going to use that piece that's already there and say, therefore, da-da! We're just declaring that the limit as x approaches 1 of f of x does not exist. In the assignment that goes with this lesson, you are going to first have to graph a piecewise function, but then after that you're going to answer questions similar to A, B, and C, and also similar to some questions that you answered in the last 2 assignments. So the questions that you're asked about the graph of the piecewise function, that's just a review of the last 2 lessons.